MagicMark, a marking menu using 2-dimensional direction and 3-dimensional depth information. The slides will be divided into the following 4 parts. I'll start with a brief introduction of the research background and our main idea, and then introduce the MagicMark technique and the experiment. At last, I will summarize my point shortly and discuss the future work. Menus are important interactive components of user interfaces, broadly applied to command exploration and selection. For large displays, RapMenu and touchless circular menus explore the design space of tiled and 2-dimensional direction. However, as one of the important input modalities, 3-dimensional depth information has not been fully utilized for menu control in large displays. Among a wide variety of menu techniques, marking menu is a very valuable contribution. It provides novice mode to perform command selection with a visible menu, and expert mode to activate a command with a straight mark. Different from traditional stroke shortcuts, marking menu and its variants can support the seamless transition from a novice user to an expert user. To extend the selection capability of large screen interaction, we propose MagicMark, a marking menu using 2-dimensional direction and 3-dimensional depth information. MagicMark is a hierarchical menu combining 2-dimensional direction and 3-dimensional depth information. A user selects the root menu with 3-dimensional depth information, and then selects the submenu item with 2-dimensional direction information. This figure shows the 3-dimensional and 2-dimensional menu visualization, respectively. The design of MagicMark can be summarized as the transition of 3 states. The main feature of this interactive design is that the transitions do not require additional confirmation gestures. Take a 4 times 4 menu as an example. First, the user holds his or her dominant hand with an activation gesture to bring up the menu. State 1. The dominant hand moves forward or backward to select the depth level in root menu. State 2. When the user makes a waving gesture that determines the depth of the menu, an item in the submenu is selected based on the gesture direction: up, down, left, right. State 3. MagicMark is a marking menu that includes both novice mode and expert mode. Figure 1a illustrates the novice mode in which a user selects the root menu with 3-dimensional depth information, and then selects the submenu item with 2-dimensional direction information. Figure 1b shows the expert mode in which users make 3-dimensional zigzag compound marks to activate the menu item. In depth interaction, users first need to strengthen the dominant arm as far as possible to complete the calibration. The length of arm length, and the calibrated menu depths of MagicMark are calculated as the following algorithm. Waving gesture is used for converting from the root menu to the submenu. Meanwhile, it selects the submenu item based on the direction of the gesture. To identify whether a wave gesture is intentional or unintentional, we use 3 adjacent positions. An intentional waving gesture is determined when the following conditions are met. We conducted an experiment to compare MagicMark and the traditional linear menu. We chose traditional menu as a contrastive technique because it was proved to be faster or less error-prone than other freehand techniques. 10 subjects participated in the experiment. We used a within-subject design. Participants were requested to complete selection tasks using 2 menu techniques. The order of menu techniques was counterbalanced using the Latin square method. In total, we collected data of 960 trials. 16 trials times 3 repetitions times 2 menu techniques times 10 participants. User performances were measured by task completion time and error rate. At the end of the experiment, participants completed a questionnaire to provide their subjective feedback for the 2 menu techniques. They were asked to rate the speed, error-prone, comfortable to use, and easy to learn, on a Likert scale from 1 worst to 7 best. This figure compares user performances between the 2 menus. Results indicate that MagicMark 2.43 seconds is significantly faster than traditional menu, M equals 2.74 seconds, P less than 0.001. There is no significant difference in error rate between the 2 menu techniques. M equals 1.88%. P equals 1.000. This figure compares subjective feedback of these 2 techniques. Results indicate that MagicMark technique is perceived more error-prone. D equals 2.57, P equals 0.01. Differences in other subjective feedback aspects are not significant. Results of the experiment demonstrate that MagicMark can significantly reduce the selection time comparing to the traditional menu without sacrificing accuracy. We attribute this performance gain to the particular selection mechanism of the MagicMark menu. To select a menu item, the MagicMark menu does not require any additional confirmation gesture, but a directional gesture. It is interesting that although the error rate of the 2 techniques has no significant difference, the subjective feedback showed difference. This might be because the experienced participants were familiar with the traditional menu technique and underestimated the errors they made. Our research can be extended in 2 ways. First, we like to compare the user performance with different menu item sizes using MagicMark. Second, we plan to explore the learning effect of MagicMark, especially the transition from novice mode to expert mode. That's all. Thank you.